Baby students, today inshallah we will study equality of two fractions. Let's start our lesson. Before we start to say that the conditions to say that two fractions were equal, let's remember together how to reduce or simplify the algebraic fractions. We have steps. Step number 1, factorize up and down. We factorize the numerator and the denominator. Number 2, find the domain, and we find the domain before simplify. And number 3, it is the last one, we simplify the like brackets up and down. So we have steps to simplify any fraction. Step number 1, factorize up and down. Number 2, find the domain. Number 3, simplify the brackets. Let's see exercise. Reduce each of the following fraction. N of x equals x power 2 minus 1 over x power 2 minus 5x plus 4. Remember with me, step 1, factorize. Up we have difference between two squares, so it factorized 2, x minus 1 and x plus 1. Down we have trinomial algebraic expression, so it will x minus 4 and x minus 1. After that we find the domain. Domain here from the denominator it will r except 4 and 1. Again, the domain it will r except 4 and 1. And the last step we simplify or cancel the like brackets up and down. So n of x equals x plus 1 over x minus 4. This is for the first part in our lesson today. Equality. When we can say that we have two fractions or two functions to say that they are equal, we have conditions. It will, number 1, domain of the first equals domain of the second. And number 2, n1 of x equals n2 of x. What is the meaning of n1 of x? It means the simplest form of the first equal the simplest form for the second. Let's see exercise. Prove that n1 equals n2. Concentrate in the conditions. n1 equals n2. Step number 1, find the domain for the first and the second, and after that, and the simplest form for the first equals the simplest form for the second. So we follow the previous steps. Step number 1, factorize. If you factorize up and down in both of them, it will like the opposite. And after that, write the domain. Domain for the first, it will r except zeros of the denominator, it will 0 and 2. And domain for the second, it will r except 0 and 2. What did you note? The first one, the domain of the first equal domain of the second. So the first condition satisfied. The second one, simplify both of them. It will x minus 1 up and x to x minus 2. Also, n1 of x equals n2 of x. It's a meaning domain equal domain. The simplest form equals the simplest form. So n1 equals n2. So we satisfy all the conditions. So we can write that n1 equals n2. Get it? Let's see another one. Prove that n1 of x equals n2 of x. Stop here. This is totally different from the previous one. We have a difference between n1 equals n2, equality between two fractions, and in the opposite, n1, the simplest form of the first equals the simplest form for the second. Here he means to find the common domain. The common domain. And he writes for all values of x belongs common domain. We have two functions. The first one, n1 equals 5x over 5x plus 10. And the second, 3x over 3x plus 6. Step number 1, we simplify. Here we have only highest common factor in the denominator. After that, we find the domain of the first and domain of the second. Here we didn't say that n1 equal n2 or the domain of the first equal domain of the second. No, we find the common domain. Common domain, it will r except negative 2. We have common domain between both of them, so we can say that n1 of x equals n2 of x. Get it? And after that, we find the simplest form. This is the last part in our session today, the homework. If you understand it very well, send the answer in a comment under this video. I hope this lesson is helpful for you. I'll be back soon with a new one. Thanks for watching and goodbye.